Hello, welcome to Quantum Online Academy. This is your Pendam. In this video, we are going to discuss about one more important topic from the classical mechanics CSIR syllabus. So that is, we are under the Lagrangian formalism. Under the Lagrangian formalism, so many varieties of the questions I am teaching to you. Maybe tomorrow that is the last topic. From the Lagrangian formalism. After finishing the Lagrangian formalism, we have to enter into the some another important questions I have to enter to you. So now you able to see in this video we have to discuss one important previous question, that is from the spring mass system. Today what we are discussing, there is a mass and spring system is there. In CSIR December 2012 this question was asked. In this question, first question if they gave, you should read 2-3 times. After reading the question, what data they are given, that data you able to see first. Three particles of equal masses are connected two identical massless springs of stiffness constant K as shown in the figure. So three particles of equal masses are there. This is the first particle, this one particle, this one is the third particle. Particles of equal masses are connected by two identical massless springs of stiffness constants as shown in the figure. If x1 and x2, you have to take x1 and x2 and x3, denote the horizontal displacements of the positions from their respective equilibrium positions of the potential energy so of the system is energy of the system they are asking, not they are giving the answers 1 by 2 k x1 square plus x2 square plus x3 square, 1 by 2 k x1 square plus x2 square plus x3 square minus x2 into x1 plus x3, 1 by 2 k x1 square plus 2x2 square plus x3 square minus x2 into x1 plus x3, 1 by 2 k x1 square plus x2 square minus x2 into x1 plus x3. So these are the answers they given. Which answer is suitable answer they are asking. Clear? Now we have to solve the problem neatly once you have to see. So here three masses are there. This is the first particle mass m. So that is the m1. That mass also is equal to m. Is connected with the spring constant k. That is the stiffness of the spring constant k. Connected to one more mass, you able to take this is the mass m2. So this m2 also is similar to m. Now you have to take this one is connected to the spring constant k, right? This mass also is you have to take it as the m3. These are the equal masses. That is also mass is going to become as a m. Now, so this m1 mass is moving in the horizontal displacement x1 position. So now this is the horizontal displacement, m2 is the x2, that m3 particle is horizontal position is x3 is moving. Clear? Now you are able to write the spring constant of this spring constant. How you have to write, already I explained to x2 minus x1 for the position of this movement of the spring constant. What is the spring constant of this? X3 minus x2, right? So the potential energy of the spring constant, that one you have to take it as a V1. The potential energy of the spring constant, that you have to take it as a V2. So therefore, you able to take the potential energy of the first V1 is equal to 1 by 2k. So which one we have to write? The first spring constant position is equal to x2 minus x1 whole square. You expand that 1 by 2k x1 square plus x2 square minus 2x1 x2. So this is the a minus b whole square. Similarly, you have to do V2 is equal to 1 by 2k x3 minus x2 whole square, which is equal to 1 by 2k x3 square plus x2 square minus 2x1 x2 2x2 x3. This is the potential energy of the second spring displacement. You able to write it is. Now the potential energy V is equal to V1 plus V2. The whole system potential energy is equal to 1 by 2k. You have to take. So you have to add these two expressions. What will happen? You have to see 1 by 2k into x1 square plus 2x2 square. Here also x2 is there, x2 is there. 2x2 square plus x3 square minus 2 into whatever the common x2 is common, 2x2 into x1 plus x3. So this is the potential energy of corresponding that problem. Now you able to see the answer. What are the answers? You have to see in our answers 1 by 2k. Now you have to see the option B. Option C you have to see 1 by 2k x1 square 2x2 square plus x3 square minus 2x2 into x1 plus x3. This option is a correct option. Option C is correct. How simple it is. CSIR is not hard, right? So any competitive exam is not hard. So they are concentrating of the student mindset only. They will give the questions based on that only. You have to apply. That is very, very important. So after applying the answer, after applying the question to get the answer is very simple. Like this, you able to solve in your competitive exam. So this is your expected answer. If you really likes my teaching, I'm informing you daily. So what I'm informing you, we started the CSR and GATE batch, that is online batch. We started. Our institute is Quantum Online Academy app. So that's why we started live class, one class in our YouTube to canvas the people why I am teaching in English only. So this is for nation, not only nation, throughout the country, throughout the world, throughout the globe, people can see these classes. So people can assume the what is the physics is going on. So where it is the physics is going on. So people will listen my class through YouTube, not in YouTube. If really they want to take the physics classes in our app, so that is the purchasable. So Quantum Online Academy app is there. So once you have to download this app through Android mobile phone, after downloading this app, you log into app. So then you go to the stores, you able to see such type of courses, CSR and GATE physics course, jail physics course, DL physics course, and separate papers also I am keeping. CSR and GATE mathematical methods of physics, CSR and GATE classical mechanics physics fully completed. Now we started the classical mechanics. More than 80% of the syllabus of classical mechanics is finished. If you have to join, now the live plus recorded classes is going on available. Our live session is 6 a.m. between 8 a.m. is there. In between 6 to 8 a.m. there is our live class is going on. So this live class you have to utilize this and you take the course. Definitely helps to you to enhance the physics knowledge much. So you have to listen and enjoy and share and like and subscribe our YouTube channel to intimate to your friends also. Thank you so much. We will meet you tomorrow with one more important, that is the motion of a body on a rigid wire, how it will be moved and how we have to calculate the Lagrangian equation. In the tomorrow's class we have to discuss. That is the last class to attempt the Lagrangian equations. Clear? Thank you.